In this lesson, we're going to continue on with our discussion of factoring. In our last lesson, we saw common factoring and difference of squares. And in all the factoring questions we get, we should always look for those first because they're the easiest types to deal with. In fact, we should always look for common factoring first because at the very least, it will make our questions easier should it come up. There's always somebody on the first unit test or on this unit test that forgets to common factor something and works with huge, ridiculously large numbers that are hard to figure out because they just forgot that one little step. So before we get into factoring trinomials, which is basically something x squared plus something x plus something, what I'd like to do is refresh our minds on how expansion works, and we'll expand and simplify these. And I'd really like to look for some common features. So I'll explain what I mean by that once we're actually done expanding here. So if I expand that out, I get x squared plus 5x plus 2x plus 10, which equals x squared plus 7x plus 10. And we'll do all three of these, and then we'll start talking about the pattern that we see. I'll go through these relatively quickly because they are review. We get x squared minus 3x plus 10x minus 30, which simplifies down to x squared plus 7x minus 30. And finally, this one, if we do the little arrows, my messy little arrows, we get x squared minus 4x minus 3x plus 12. And that's x squared minus 7x plus 12. Okay, so now a little observation. All of my answers start off with an x squared. If I look back into the original binomials, I notice that all of them are x plus or minus something times x plus or minus something. So the numbers in front of the x's are all ones. Then I'm going to look at the last part. 10, well, that's 2 times 5. Minus 30 is 10 times negative 3. And 12 is negative 3 times negative 4. So that n number is always going to be those two numbers from the original question multiplied together. Okay, that one's pretty easy to see. Now I'm going to just take those out for a sec. And I want you to notice that this number here is equal to the sum of the two numbers, 2 plus 5. 7 is 10 minus 3, and negative 7 is negative 3 minus 4. So in all of these, it seems like the n number is the two numbers multiplied together, and the middle number, the one in front of the x, is the two numbers added together. So we're going to use that pattern to try and factor these out. So what I want here is two numbers. I'm just going to make a little note up here that multiply to 6, add to 5. And it shouldn't take you too long to come up with something that works here. I'm going to tell you that when you look at the multiply number, in this case it's 6, if it's positive, it means that both the numbers are positive or both the numbers are negative. And since the number in front of the x is positive, they're both positive. So I'm looking for two positive numbers that add to 5, multiply to 6, and I think that's pretty obviously plus 2 and plus 3. All right, now that we have those two numbers, we can write them as x plus 2, x plus 3. And sure enough, the 6 at the end is 2 times 3, and the 5 in the middle is 2 plus 3. That's it. All right, so let's try it for the next one. We're looking for two numbers that, I'm just going to abbreviate this to multiply to 24 and add to 10. Again, I know they're both the same sign because they multiply to a positive. I know they're both positives because they add to 10. So I'm looking for something like 1 times 9, 2 times 8, 3 times 7, 4 times 6. Actually, 4 times 6 works. So if 4 and 6 work, this just becomes x plus 4, x plus 6. And a quick double check, 4 times 6 gives me the 24 at the end. 4x's and 6x's gives me 10x's. Let's keep the pattern going, but now we're going to deal with some negative signs and see how that changes things. This time we're going to multiply to negative 20 and add to 8. So before I even try to guess numbers, the fact that they multiply to a negative means that one of them is negative and one's positive. And the fact that they add to a positive means the positive number is the bigger magnitude of the two. So this is going to be something like 9 minus 1, or 10 and minus 2. And actually, 10 and minus 2 seem to be the ones that work. Ten minus 2 gives me 8 when I add them. 10 times negative 2 gives me negative 20 when I multiply them. So again, use the signs of the things you're multiplying and adding to tell you roughly where to start. On this one, we're looking for two numbers that multiply to 14 and add to negative 9. They multiply to a positive, which means they're the same sign. They add to a negative, which means they've got to both be negatives. So I'm looking for something like negative 1 and negative 8, or negative 2 and negative 3, negative 2 and negative 7, negative 4 and negative, I'm losing track here. Oh, wait, no, I just passed it. Negative 2 and negative 7. Those are the two that work. Those do, in fact, add to negative 9 and multiply to positive 14. Okay, so usually trial and error shouldn't take you more than a couple, and most people will see them pretty quickly, I think, as long as the numbers are reasonable. All right, on this one, we're looking for two numbers that multiply to negative 15 and add to negative 2. So I know because the multiplication is negative that they have opposite signs. And because they add to negative 2, I know the bigger magnitude number is negative, and then there's a smaller positive number that brings it back closer to 0. So that would be like negative 3 and 1, negative 4 and 2, negative 5 and 3, and negative 5, 3 works. Since those numbers multiply to negative 15. All right, F. First problem we've got here is that we don't have a 1 in front of our x squared. So that seems like it's going to be a complex trinomial, which we're about to get to in a moment, which makes me wonder why I would have put it in question 2. Until I realized that I should always try and common factor first to see if that makes my life easier. And sure enough, I can common factor a 5 out of this. So when I common factor a 5 out, I'm left with x squared minus 9x plus 18. I'm looking for two numbers that multiply to 18, add to negative 9. I know they have to have the same sign. I know they're both negatives. So that would be negative 1 and 8, negative 2 and 9, negative 9. Let me try that again. They both have to be this negatives. They add to negative 9, negative 8, negative 1. Actually, negative 8, negative 1 work, doesn't it? That will, no, that doesn't multiply to negative 18, or to 18. Negative 8, negative 1, negative 2 and negative 7, negative 3 and negative 6. That's the ones that work. Those add to negative 9, multiply to positive 18. Now, if we learn the method that we're about to, the complex trinomials, or if you remember from grade 11, we could have done this as a complex trinomial, and it would have taken forever because we'd be looking for huge numbers that multiply to massive things and add to big things, and it would have taken us a long time. But if we common factor first, it would have taken much less time. So the only difference between what we just did and what we are about to do is that now we're looking for things that have an a in front of the x squared other than 1. So we're looking for something with multiple x squareds. Again, before we do that, I'm going to expand out a few things and see if we can look for patterns. This one, I'll be honest, isn't as nice, but don't worry, I will tell you what you need to know to get them right. When I expand this out, I get a 3x squared plus 6x plus x plus 2, which is 3x squared plus 7x plus 2. This one, x times 5x is 5x squared plus x minus 15x minus 3, which is 5x squared minus 14x minus 3. And this one here, 4x times 2x is 8x squared plus 20x plus 6x plus 15, or 8x squared plus 26x plus 15. Now, I'm not going to try and point out a pattern as good as the one that we saw with the simple trinomial factoring. I will show you that the two numbers multiplied together, the 1 and the 2, give me the end number. And the numbers in front of the x's multiplied together, in this case 3 and 1, give me the starting number. The middle number is a little bit more complex, so I'm not going to worry about that right now. But again, I'll point out negative 3 times 1 is negative 3. 1 times 5 is 5. 3 times 5 is 15. 4 times 2 is 8. So there's definitely a bit of a pattern here, but it's not as strong as the other one. That's okay, though, because we can actually do a little trick. Now, that said, this little trick is going to be kind of like the other one where we're searching for two numbers, but it's different as far as what we do with those two numbers. So I'm going to teach something called the decomposition method. I'd like you to do it this way on the tests and everything else. In class, other students have said, oh, I've got a better way that works. And there is another way that works equally well in theory, but students tend to get it wrong more often. So all the students that tell me they've got a better way of doing things on the test, they do not do as well. They make more little silly errors. So if you've seen another method, just take your time here and see if you can follow the method I'm going to show you, which is called decomposition. And it's a skill that we'll actually kind of use somewhere else anyway. So paying attention to it now won't hurt. Okay, so before we were looking for a number that multiplied to the n number and added to the middle one. Here what we're going to do is we're going to find a number that multiplies to the n number times the first number. So we're looking for something that multiplies to 2 times 5 is 10. Now technically this method would have worked if that was a 1 in front. It just simplifies down to the method we just learned. But it's similar. And we're looking for two numbers that add to 11. They're both positive. In this case, the two numbers are 10 and 1. But I'm not just going to put down x plus 1, x plus 10 in the brackets anymore because I've got that 2 in the front. So here's what I'm going to do. I'm going to think about how I expanded and go backwards. We got this 7 because it was a 6 and a 1. And we got this 14 from 1x and minus 15x, and this 26 from 20x and 6x. So what we did is we took two x terms and put them together to get one x term. Here we're going to decompose the middle term to get two terms. So really what I'm doing is I'm breaking this 11 into two separate pieces. And I'm doing that based on the two numbers that I found here. So the 11x becomes 1x plus 10x. That's why we call it decomposition. We're decomposing the middle term into two pieces. Then what we do is something called partial factoring, where we're going to take the first two terms and common factor them, and the second two terms and common factor them, but we're not trying to common factor all four terms at once. So here, 2x and 1x, this should be a 2x squared. My mistake. 2x squared and 1x, all I can factor out of that is x, and I'm left with 2x plus 1. And then those second two I can partial factor. I can pull out a 5, and I'm left with 2x plus 1. And if I did it right, what I have is the exact same bracket in each of them. In this case, 2x plus 1. So the first part says I have x of that bracket. The second part says I have 5 of that bracket, which means in total, I have x plus 5 of that bracket. And there's my factored form. So it was a little bit trickier to get the actual numbers. I can't just say find two numbers that meet the criteria and then it's x minus 1, x plus the other, whatever. Here we have to do the decomposition. But if you could do the decomposition, the partial factoring, it's actually pretty straightforward. Again, if you're trying to use a different method that you may have learned in another course, you may find that you get the signs wrong more often than this way. This way it almost stops you from making any sign errors. You're probably just as likely to get the numbers right, but you have horrible sign errors in the other method. All right, we're going to try the same thing in this one. We're not going to multiply to 1. We're going to multiply to 1 times 12, which is 12. And we're going to add to the middle number, which is 7. So two numbers that multiply to 12, add to 7, they're both positive. The two numbers are going to be 4 and 3. So what I do is I decompose that middle term into two separate numbers. By the way, the order that you do this doesn't matter. You could do 4x and then 3x or 3x then 4x. It'll change the order you find the two brackets, but that's about it. So 12x squared plus 4x plus 3x plus 1. There's the decomposition. Partial factor first two and second two separately. Partial factoring the first two gives you 4x, 3x plus 1. 3x and 1, there is no common factor there, so there's just one 3x plus 1. And that gives me 4x plus 1, 3x plus 1. Again, I've got 4x of this bracket, one more of that bracket, so I have 4x plus 1 of that bracket. Hopefully this is starting to make sense, if it didn't already. Okay, this one, I see these big numbers, and the first thing that comes to my mind is I should try and common factor this. Unfortunately, 29 is a prime number, so there's no way I can common factor. This one's going to be nasty. But again, I want to put in a couple that are nasty to show you that they're still quite doable. So what we're going to do on this one is look for two numbers that multiply to 12 times 15. Oh, geez. 12 times 15 is 180. So multiply to 180 and add to 29. Okay, so we know they're both positive numbers. Pick any two numbers that multiply to 29 and that add to 29 and see if they multiply to 180. So I could try, I don't know, 10 and 19. Well, 10 times 19 is 190. So I try two more. 25 and 4. 25 plus 4 is 29. 25 times 4 is only 100. 20 times 9. 20 times 9 is 200 and... Sorry, no, 20 times 9 is 180. So there's our two numbers, 20 and 9. All right, decompose that middle term. 29x becomes 20x plus 9x. And again, you can reverse the order of those. It'll change the next step, but you'll still end up with the same answer, just with the brackets in opposite order. Common factor those and those. First one, I'm going to factor out 4x, and I'm left with 3x plus 5. And here I'm going to factor out a 3, and I'm left with 3x plus 5. And if you don't get two identical brackets, you know you've made a mistake, because that's the whole point of decomposition. And now I have 4x of that bracket plus 3 of that bracket is 4x plus 3 of that bracket. And you can expand that out and double check to see that it works, but it will. Okay, for the remainder of these, if you want to watch me keep doing them, great. If you want to pause, try them on your own, come back and double check the answers. You can do a little bit of skipping to see that the final answer is right. Whichever makes you happy. The more that you try independently, the better you'll probably get at this. But I'll keep going, assuming that we're still watching. So 2 times 3 is 6. I'm going to multiply to 6, add to -7. And that would be -6 and -1. So this equals 2x squared minus 6x minus x plus 3. Partial factor those first two. That's 2x x minus 3. And the second part, you'll notice, is a minus x plus 3. I'm going to actually factor it a -1 to get x minus 3. And it's what makes those two brackets then identical. So I then have 2x minus 1 times my bracket x minus 3. All right. Next one. Two numbers that multiply to -42 and add to -41. And that would be -42 and +1. That should work. All right, so we get 6x squared minus 42x plus x minus 7 equals 6x, x minus 7 plus 1, x minus 7 is 6x plus 1 times x minus 7. These, by the way, are the hardest type of factoring, so if you can get these done, you can do pretty much anything. This one, 15, 26, and 8. 15 is not divisible by 2. 26 is not divisible by 3. I think we're stuck. So we're going to get larger numbers here again. 15 and 8 multiply out to 120, so that we're looking for two numbers that multiply to 120, add to -26. And I think those numbers are going to be -20 and -6. So 15x squared, just for the heck of it, I'll do the -6 this time first, and then the -20. Again, order really doesn't matter. It'll always work. Partial factor those first two and second two. 3x, 5x minus 3, minus 4, minus 5, no, minus 4. 5x minus, wait a sec here. Oh, I goofed. See? I noticed this bracket, second bracket is going to be different than the first one. 6 divided by 3 is 2. There we go. 5x minus 2. 3x minus 4, 5x minus 2. Expand it and see what happens. Getting close to the end. This one here, 18x cubed plus 15x squared plus 3x. Okay, first I'm going to notice that this isn't even, it's got an x cubed in it. There's no constant term. And hey, they're all divisible by 3 as well. So first thing I'm going to do is common factor, because I should always check to see that that's doable first. I'll pull out a 3x from each term, and that leaves me with 6x squared plus 5x plus 1. And now I'm looking for two numbers that multiply to 6, add to 5, and those numbers are 2 and 3. I'm going to decompose the 5x into plus 2x plus 3x. Partial factor the first two terms. And I get 2x, 3x plus 1. And this one, 3x plus 1, I can only get one of those out. So that becomes 3x times 2x plus 1 times 3x plus 1. Now, did I have to, well, I guess I kind of had to common factor with the x if I wanted it to work, at least somewhat nicely. But if I hadn't common factored out the 3, I could have still done this. It just would have been really nasty because I'd be looking for two numbers that multiplied to 54 and added to 15, and it would have taken me a little longer than two numbers that multiply to 6 and add to 5. All right, one more. Two numbers that multiply to negative 8, add to 5. Okay, so two numbers that multiply to negative 8 and add to 5 means they have to be opposite signs. So they multiply to the negative, and they have to be, one has to be a positive number bigger than 5, and then a small negative number that brings it back down to 5. So that could be like 6 minus 1, 7 minus 2, 8 minus 3, and none of those are multiplying to negative 8. Ooh, that's a weird one. Okay, so if you get one like that and you're like, oh, geez, I'm not sure exactly what the problem here is, but there seems to be something wrong. Here's what I'm going to ask you to do or try. 2x squared plus 5x minus 4. I'm going to go to Desmos. And I'm going to open the graphing calculator. And I'm just going to put in that polynomial as a function. And it was 2x squared plus 5x minus 4. And I can see that it looks like this. Now, here's the neat thing. While this is a little bit of cheating because we won't necessarily be using Desmos for everything, I want to be able to do these kinds of questions algebraically. I can use this to show that the two roots, or the two x-intercepts, are not whole numbers. They're actually really nasty numbers. And what that means is that if I go back to the original, it's not factorable because the two numbers that would multiply to negative 8 are negative 3.13746 and 0.63746. And those two numbers also will add to positive 5. They won't add to positive 5, will they? What did we do wrong there? Oh, sorry. They don't have to add to positive 5 because they don't. We're just looking for the two numbers that we decompose, not the two numbers that are our actual final answers. But the point is the two numbers that we're looking for are not integers, not nice numbers, so we're not going to find them. So Desmos didn't solve the problem for us, but Desmos at least showed us that we're wasting our time in looking for a problem here. So what we're going to do from there is just simply go back to the problem, and we can now verify that this is not factorable. And if you think, anytime you think that it's not factorable, instead of just making that assumption, throw it into Desmos. Sometimes you'll notice that there are actually whole numbers that are nice, in which case you kind of have a little bit of your answer. You know there's an answer worth looking for in case you didn't see one before. But if you get non-integer answers, then yeah, there's nothing you're going to be able to do that are going to fix that. All right. Practice problems, try factoring some different things. Answers are at the bottom. Once you're done, check your answers. If you're getting them right, great. If not, let me know, and I will do what I can to help. We will see you in the next lesson.